Good morning, brothers. This is Mr. Ellis. Unfortunately, I didn't get your video done last night, so I'm doing it this morning. You will find it during the Estoville period. I will send out an announcement on. You probably will be able to view it tonight before the next day's class. Okay, let's get started. First thing we're going to talk about here is the fact that an array is a subscripted variable. We've experienced the declaration of variables before. Let's go in and declare some variables. Okay. First, let's look at integers. If I want to declare an int, okay, I could leave it as uninitialized. It will reserve for me a 32-bit space in storage for K. It'll be labeled K, but K has nothing in it at this point. Okay. If I want to assign a value to K, now it reserves the space and then assigns a value, which this case would be 2. So K is equal to 2. I want to look at a subscripted variable. It's known as an array. To declare an array, I will use the same specifications for storage. Integer, give me 32 bits of integer space. And then I specify that it is an array. Okay. I give it a name, just as I did with K. This one is going to be even, if I could type, I'd be dangerous. Even nums, okay? And it's an object, so I use the new keyword. And then I specify how many of these 32-bit storage locations I want. I would say we're going to do 10, so just int 10, and of course everything ends with a semicolon. Okay, so now let's compare. We know that these are integers. Both are integers, and they're both getting 32 bits of storage. This one receives a single 32-bit storage location. This one receives a 10 times 32 bits of storage location. Okay, so we get 320 bits divided up into 32 sections. 32-bit sections. There's 10 of them. Okay, all right. I would like also for our demonstration to declare a boolean. Okay, and as always, I'm going to set mine to true. It's not necessary to set it to true. You can set it to false, but I prefer the positive outlook. Okay, now I have these guys declared, I need an index. This is going to work as an index for my array. So I'm going to start him at 0. And there you go. Those are the declarations that I need for my demo. Now, what we like to do here is to create a loop that will print all the even numbers to the console. At the same time, I would like to assign all the even numbers, the first 10 even numbers, to an array. The array's name is even nums. Okay, so this procedure will use a while loop, and I'm going to control my while loop with the flag variable, which indicates positive or true. When I just say flag, it means true. If I say not flag, it means false. Okay. I need to have some curly squirrely brackets there. And I'm going to, inside here, I would like to type the logic for determining if a number is even and for assigning them to our array even nums. So I will type that and get right back to you. Okay. Here you see that I've typed in the logic or the statements needed to accomplish the task that we've specified we're going to do. First, I want to check to see if k, our number, is even. Because I started with 2, it is going to, upon entering the loop, already be even. Okay. I'm going to take, if it is an even number, and assign it to the element in even nums that we're currently on. Then we started with 0, so we start here with 0. I assign that even number to it. Okay. I'm going to print out the number to prove that it has been assigned to that even nums element. I'm going to print the element out. Okay. Then I'm going to increment my number plus equal 2, which makes it from 2 we go to 4, from 4 we go to 6, from 6 we go to 8. All of them are going to be even numbers. Okay. And then I increment my index variable by 1. To end this loop, I have to turn my flag off. I want to determine if it's time to turn my flag off by the index. If I am at 9, 0 to 9 means I've assigned 10 elements. Or if I am over 20, then I've passed the first 10 even numbers. So I will set my flag to false. This should work very very well. As a matter of fact, we've done it in class. You guys should have this code. So I'm going to run it to prove that it worked. Here we have 2, 4, 6, 8 up to 20. From 2 to 20 is the first 10 even numbers. Okay. So it did work. Now, what I'm going to do here is I'm going to do the same thing without all this overhead by using the new loop that we learned called a for loop. Okay, and as I type this, I will hopefully be able to indicate to you why a for loop is used for arrays. Sorry for the interruption, brothers. As you can see, it has assigned the values, all the even numbers between 0 and 20, in the even nums array. Okay, because this printout came from that element, each element. As it was loaded, we printed it out. Okay. Now, problem with this is the while loop has a lot of overhead. Okay. You have to have a control. You have to have index. Okay. And you have to calculate the values. Well, what if we were to use a loop, for example, a for loop, that would allow me to have all of these elements that it takes to use a while loop in the one loop in the header of the for loop. Now I'm going to go over that here. So in order to do so, I'm going to wipe out some of this. Okay. Instead of a while loop, we're going to use a for loop. I'm going to go for, okay, and what are the parts of a for loop? Well, first we need the variable. The loop counter will be an integer. I'm going to call him x. I will initialize x to 0. Not necessary, but because I'm doing arrays, and the for loop is perfect for arrays, I'm going to initialize x to 0. Okay. Then I need a condition. My condition will be if x is greater than less than 10. Okay. All right. It turns itself off as long as x is less than 10. When x becomes equal to 10, then it'll turn itself off. Then I need an increment. The increment will be x plus plus. Now, this could be an increment of any value. You can increment x by x plus plus equals 2, or x negative negative, which will decrement your variable. Okay, so we are able to change that loop counter any way we want. I suggest that when you're doing arrays, you're going to use that as your index, so you will increment by ones. All right, now that we're using a for loop, we want to check to see what changed in the body of the actual task. Okay. First, I'm still going to check to see if k is even. I don't need to increment x because it's automatic. So I'm going to take that out. In here, I'm not going to increment. The declaration of x is done in the loop. The incrementation of x is done in the loop. The checking to see if it is out of bounds is done inside the loop. I don't need the flag because it's going to turn itself off when x is greater than 9. Okay. Right here, the or for this is not unnecessary because I'm not checking. Okay. I'm still going to check to see if k is greater than 20 and turn the flag off because I want only the first 10. So we were able to do away with a lot of code by using the for loop instead of the while loop. And I think what I'm going to do here is keep my array, keep my increment. Okay, so let's run this and see if this works the same way. We should have the same output. So I'm just going to destroy that so when we look at it. There's an error somewhere. Error flag is no longer needed. So I can just turn that off. It's not going to go past 20 because I'm only going 10 times through here. Okay. And hopefully it will. Let's take some insurance here. At the top here, I'm going to do something that I'm going to add an and. Say k is less than 21. And that way, we won't have to worry about it going out of bounds or doing more than the first 10. Let's see if that works. Save it and run it. And what do we get? We got the first 20 even numbers. This has been a demonstration of single dimension array and the use of the assignment, the instantiation, the assignment, and the printing of array elements. Thank you, Mr. Ellis.